Hello, welcome to today's class on understanding geography with diagrams. Today we'll be talking about air masses. So basically I have decided that I will be teaching from my notes as most of you are not able to catch up with the notes as well as videos. So basically I will also be referring to my notes while I will be teaching so that you could have a clarity of thoughts, rather what to follow in the notes and what to follow with the help of diagrams. Now let's move on. See, basically we have over here air masses. Now it says that air masses are nothing but your three-dimensional homogeneous mass of air are defined to be your air mass, which climatologically functions as your thermal engine, regulating the weather mechanism. The homogeneity of the air mass is measured in context to the temperature and humidity, with both the properties sourced from the surface of the earth. It simply means that homogeneity of the air mass means that the air mass is equal in all proportion. Now, which are the two things that we are taking into consideration to see such homogeneity? We are temperature and humidity. That is, the basically the air mass has equal temperature throughout the entire body, as well as the humidity is nothing but the amount of water vapor within the air mass is also constant throughout the proportion of the air mass. Air next, air mass develops stronger characteristics during the winter season. It's completely uh, why now basically you'd say that why the air mass develops a stronger characteristics during the winter season. It's basically the thing is that air mass has a stronger characteristics both in your summertime as well as your winter time. But during the winter time, but during the summertime, what happens is that there is an unequal heating of the land and the basically the land and the nearing surface. Whereas in the winter seasons, what happens is that though the sun rays are there, but it's quite slanting, and there is no stark difference in the temperature. So basically I think you got the point that air mass develops a stronger characteristics during the winter season. Now that part of the earth's surface from which the air mass attains the physical property is called as the source area. This is quite a simplistic statement that you can understand. Practical, Practically the entire surface area of the earth qualifies to be the source area. Practically the entire surface of the earth area qualifies to be the source area for the air mass, barring the exception of the mountainous region. Why mountainous region? Now basically in a mountainous region what happens is that the topography is undulating, means it's not equal, hence there is no proper plain area over which the air mass can develop. That's why the mountainous area are not that category of the means not suitable areas for the development of the air mass. Next, for the air mass barring yes, and air masses developed in their respective source area are recognized to be the barotrophic air mass. That is, what is a barotrophic air mass? The air mass that has been developed in the source area, it's called as the barotrophic air mass. Now, movement of the barotrophic air mass in effect of the prevailing wind makes them influence weather condition of the advected area. What is the advected area? Advected area is nothing. If this is A, this is area B, wind flow from A to B. So, which is the advected area? Obviously B. It's that simple. So, it says that along with getting influenced by the prevailing condition of the affected area, the modification of the air mass is identified to be representing both the conduction and convection. Okay, the air mass, whichever area that the air mass goes, it's actually what happens is that the air mass is also modified that by that area, and the air mass itself modifies the area. So vice versa, if air mass reaches this area B, so this air mass will be influenced by the persisting climatic condition of the B, and the B will be influenced by the air mass. There would be a reciprocity. Next, and that When the air mass adopts the prevailing condition of the advected area, that air mass would be called as the baroclinic air mass. So basically you understood two terms over here we basically faced. One is your baroclinic air mass and another is your the barotropic air mass. Air mass which has the properties equivalent to the area from which it is sourced is called as a barotropic air mass, and the air mass when it is being modified by a particular area it's called as the baroclinic air mass, modified by the area to which the air mass has traveled. Remember that. Next, climatologically air mass are classified on the basis of your latitude number 1 and your relief number 2 as major categories. Among the minor demarcation, temperature. So basically categorization of the air mass is done upon your the major category, that is your latitude is one of the major category and relief is another major category. There are also minor demarcation. You have your temperature over here. Let's convert this to blue. And next we have the stability are also taken into account on the four bases of the air mass. So on this see on all the four bases two types of air masses are distinguished, which combines up to the 16 different types of air mass. For the global climatological analysis, however, the four major type of the air mass is classified on the basis of the latitude and relief. So basically it says that there are the 16 different types of air mass, but from the climatological perspective we are taking four major air mass into consideration based on the latitude and the relief. Now basically air mass will be categorizing into the four categories. All the four. Now with respect to while categorizing the air mass, we will also be studying about its impact, its global impact. All the four major air masses induce a significant range of the weather effectivity in their respective areas of influencing. It is in terms of the diversity of the weather condition and size influence area that the air masses are arranged in order of the importance. So basically it is the area, it's the size and the influence over the area that air masses are arranged in accordance to of their importance. The number one important air mass that we will be studying is your continental polar air mass. The second would be your maritime tropical air mass. Third, your maritime polar air mass. Last but not the least, the continental tropical air mass. Now let's come to the maritime polar air mass. So basically the maritime polar air mass is the cold dry air mass which relates to two different sources area. One is your Canada, another is your Siberia. Both this perennial air mass becomes extensive during the winter. Okay, this southward extension makes them induced cold weather condition in the low latitude countries like the USA, China. In the support of the stronger polar outbreak, Canadian air mass induces stronger effectivity. Okay, I hope this is quite clear. Then the Siberian counterpart. Apart Siberian counterpart, that is Purgas, as they are hindered by the broken orography. If you have seen the local winds video, then I'm quite sure that you would have understood that why the Canadian blizzard outbreak is more stronger than the Purgas that occurs near the Siberia, China, because I have clearly stated over there the very reason. I hope if you have not watched the video, then I would request you to go back and watch the video for the clarity. Apart from this weather effectively, southward extension of this air mass makes them come in effectivity with the westerlies. This movement towards the northeast makes them develop the Arctic front. We'll understand this one by one, that when they move towards the northeast, they develop towards the Arctic front along the shoreline. It is in the effect of this front that the coastal area experiences their winter precipitation. It is the Arctic front provided in the northeast that results in your coastal precipitation. In the weather effectivity also, the Canadian air mass proves to be stronger as it encounters the warm oceanic current shoreline compared to the Siberian counterpart. Okay, it says that the Canadian air mass is also proves to be stronger when compared to your Siberian counterpart. How? Basically, it leads to the Canadian air mass occasionally develops your squall line at the convergence of the exponentially cooled continental tropical air mass and exponentially warm maritime tropical air mass from the Gulf of Mexico generates exceptional turbulent weather condition. Now, please understand this. We'll use the diagram extensively. Now, mhm, this is number one and this is number two. See, basically, two things you need to see over here. First of all, air mass. This is your, as I said, Arctic. This is your blizzard, and this is over here, none other than your that is your purgas. Purga, this is your blizzard category. That is nothing but your continental polar air mass. I say CP air mass. Now let us understand the CP air mass category with respect to your North America. Now when the CP air mass comes over here, basically what happens is that in the northeast, it and what happens that it forms a front over here. It leads to your precipitation. This precipitation is nothing but your frontal precipitation. The frontal precipitation occurs both in land as well as water. Now, what happens is that if the continental polar air mass it it moves towards your the southern part. Now, while it moves towards your southern part, it will first of all face the Great Lakes. And what happens near the Great Lakes? It basically results in your the Great Lake effect. What is this Great Lake effect? Great Lake effect is nothing but your snowfall. And this snowfall has occurred because of the influence of your continental polar air mass, which is moving southward. Now, as it moves southward, this is your it comes when near to the Gulf of Mexico. What happens is that this cold air mass will meet the warm tropical maritime tropical air mass. Now, this movement will result in the formation of your, as I had said, squall line. And this squall line is very dangerous, as you will learn in the coming classes. During the time we would be learning this temperate cyclone. The squall line results in your tornadoes. I hope you got this. Next, let's come over here. Next to the next important category is your maritime tropical air mass. Now, maritime tropical air mass, as the name suggests, is nothing but a warm, moist air mass that correlates to the low latitudinal water bodies. These air masses commonly correlates to the development of the wetter. WETTER means a wet condition, wetter weather condition. These are classified on the basis of the consistency of the weather influence as permanent and temporary. So basically, the maritime tropical air mass will be classified as the permanent category and the temporary category. The permanent category, first of all, let's discuss, includes the maritime tropical air mass as a unique example of which marks its effectivity over the entire equatorial belt throughout the Earth's interior of the land and water. It is with this air masses that perennial absolute instability and convectional precipitation is mainly associated. Permanent maritime tropical air mass also belongs to the open sea, representing the open Atlantic, that is your Azores High, and your Pacific High, or the Hawaiian High we call it. Next, these air masses register their mobility in the effect of the trade winds, facilitates the development of the ITCZ in the effect of the westerlies, facilitates the development of the polar front. both ITCZ and the polar front being the significant regulators of the precipitation in the lower and the higher latitude respectively. I hope if you have already watched my video, then this would have been very easy for you. Still, I'm quite confident that most of you have not watched my videos, hence I have to explain you again. It's very simple. Look at this. See. Yes. Yeah. We'll draw with the North America again. We'll just reduce the. Yes. See, basically, we had talked about two things. First is that we talked about the maritime equatorial air mass. This maritime equatorial air mass, it influences your none other than your equator. Sorry, it should be like this. This influences your equator. Now, from where does what is the source of this? Now, the source is simple. It's your Azore High over here, and this is your Hawaiian High. Both the Azore High and the Hawaiian High becomes the source from which the wind are derived. Similarly, the Hawaiian High and the Azores High also results in what? They also result in your polar front or your polar low. Over here, they result in your equatorial. Wait, let's use this. This is your equatorial low, polar low, and the equatorial low. These are the two created by your Hawaiian High on one hand and the Azore Highs on other hand. This is what it is trying to say. Next is that within that we have the temporary category. Now please understand this temporary category is very easy. Includes the air mass of the marginal water bodies which though are permanent in their existence includes weather effectivities only in the particular season. For example, the tropical marginal water bodies of the Gulf of Mexico, Bay of Bengal, and the South China Sea. Weather effectivities are generalized during the summer when the neighboring land develops the low pressure, attracting the air masses, resulting in the monsoonal rain. You can also talk about the Kal Baisakhi in this case. It's only in the case of the Mediterranean Sea that the maritime tropical air mass, called as the maritime Mediterranean air mass, registers effectivity during the winter in support of the onshore westerlies. Next, we have your maritime polar air mass. See, but prior to discussing, let me again say you this temporary category is nothing but it's talking about your sea breeze. It says that land gets heated and the water will be attracted from your neighboring sea. And then it's a maritime polar air mass forms the cold, moist air mass typical to the northern Pacific, open northern Atlantic Ocean. This air mass induces weather condition effectivities in terms of facilitating the polar front and the Arctic front. I hope you understood what was this maritime polar air mass. First of all, it's a cold, moist air mass which has been formed in the northern Pacific or the open North Atlantic, the Greenland region areas. These air mass induces the weather effectivity in terms of facilitating the polar front, okay, and the Arctic front. Unlike the maritime tropical air mass, it relates to the conditional instability only. We have to take a class of this instability where I will be discussing what is the difference between absolute and the conditional instability. Next, we have the continental tropical air mass. What is it? The warm, dry air mass typical to the tropical land mass induces dry weather condition. It's simple. Simple, we can say that the continental tropical air mass is inducing a dry weather condition. It is in this effectivity of this air mass that during the winter, entire tropical land mass remains generally dry. It's very easy. It says, please read it over here. It says, the western margin land of the tropical desert remains dry throughout the year. I'll just explain this to you. See, basically all over the world you'll find that the western side of the continent is basically the desert. Let's again talk of over the world's largest desert, that is your Sahara Desert. Now, entire Sahara Desert is nothing but the prevalence of a high pressure zone, and this high pressure zone results in your offshore wind. Already in the local winds we had studied over here with respect to your Harmattan. Again, we had studied of the Sirocco, and again we had studied over here is your Khamsi. It's basically this is the high pressure region or nothing but your continental tropical air mass. First of all, it is continental means it's in the continental interior, and tropical means it's in the tropic area. Hence, this air mass that continuously flows, as a result of which it leads to that the western side of the continent always remains in a dry desert. Why? Because as you can see, this air mass is basically pushing away the air mass. Means basically what is the thing? The thing is that key land gets heated, so air from the nearby ocean will flow towards the land. But it is this prevailing of this air mass. What happens is that it actually pushes away this maritime tropical winds, and as a result of which it remains dry over here. I hope you understood this. Thank you for today's class. We'll be moving on to the temperate cyclone and the tropical cyclone in the next class. And I would suggest people to study about the different types of orographic, different types of precipitation. And with this, we would have two questions. Question number one: air mass and their effective and their global effect on the weather. Next, types of precipitation. I have clearly given the types of precipitation in my notes. Thank you.